Okay, so the first thing I want you to do is you're on that third page of the notes packet right here, there, and we're just going to solve inequalities with multiplication and division today. So we've solved inequalities with addition and subtraction, and we found out that the structure and the process of solving inequalities with addition and subtraction is literally the exact same thing as solving equations with addition and subtraction, right? The only difference is you have to keep track of the sign. You have to keep track of the sign. That's going to be the same thing today. But keeping track of the sign is going to be a little bit more tricky today than it was yesterday. So we're going to kind of take a look at a quick exploration. So, why is it not shifting over? Come on. Yeah, right? It's going to freak out right now, I bet. Let's try again. That's my math Fortnite dance, right? It's good stuff. Anyway, so we know that 6 is less than 12, right? Is that a true statement? 6 is less than 12, it says it right there. But what happens when we multiply both numbers by a common multiplier? So what I want you guys to do is, with your partner, I want you to go through and do this multiplication. Just do all the multiplication. 6 times 3 is 18, and 12 times 3 is good. So I want you to go through and get all of that multiplication for all 7 of these. Then I want you to go through and assign the symbol. 18 is what compared to 36? Less than. So I want you to go through and do all the multiplication for all 7 of them. Then check then go through and do the signs. Okay? So do that with your partner, checking those signs. Just do the multiplication. Just do the multiplication.
I see a pattern.
You should. Do the multiplication. You guys see my remote anywhere? Maybe it's in the drawer. There it is. All right, so these are the numbers we should have, right? Well, you should be done because the numbers on the right-hand side are the exact numbers on the left, just with a negative sign. Okay, so now we need to get our symbols, right? So the first one is less than. Keep in mind, what did we start off with? Started off with 6 is less than 12, right? Every single one is 6 is less than 12 because everything is a multiplier of 6. So 12 compared to 24 is 12 is, everyone says together, 12 is good, less than 24. 6 is good. 0 is what compared to 0? Equal. Wait a second. Symbol changed. Weird. So when I multiply, sometimes the symbol could change, huh? Interesting. Okay. What about negative 18 compared to negative 36? Negative 18 is greater. What? Negative 12 is what compared to negative 24? What about negative 6 compared to... Wait a second here. So this statement, 6 compared to 12, is 6 is less than 12. But when we multiply it by stuff, what happens? Okay? Things can change, can't they? So let's answer this question. What happens to the direction of the inequality symbol as you multiply by a positive number? What happens to the direction when you multiply by a positive number? Nope. Let's answer the question here. What happens to the direction of the inequality as you multiply by a positive number? Which of these multiplications is a positive multiplier?
Left to the top.
Top left, the first 3. What happens to the symbol? Remember, our original symbol was this. This is our original problem. 6 is less than 12. What happens to the symbol when you multiply by a positive number?
It stays the same.
Stays the same. Stays the same. What happens when you multiply by a negative number? It flips, it changes, it flips. So, when you multiply by a negative number, it flips. When you multiply by a positive number, it stays the same. So remember, it's like flips. Oh! Anybody in this class do a flip?
I can.
Last year, we had a cheerleader who could do a standing back tuck. You know what a standing back tuck is? It's when you stand and you just do a backflip and land on your feet.
How do people do
I don't
that?
remember.
I
I can't remember who it was. But it was awesome. Yeah, Sakai can do it. So during second period, Sakai's going to come up here and flip. Because it makes the lesson more fun when someone can do a backflip, right?
Oh yeah.
So let's take a look. Here are our rules. This is the big part, right? This is the part of your notes. Shh. Thank you. This is the part of the notes that is big. And that's your rules, okay? So our rules for solving inequalities using multiplication and division, okay? If you multiply or divide by a positive number, the inequality symbol, okay, what happens? So we've got these in here. You multiply by a positive number, the inequality symbol will do what? Stays the same, okay? And we can double check that, right? If this is our original, if negative 8 is less than 4, is that true? Is that true? And I multiply negative 8 by 2, and I multiply negative 2 by, or excuse me, I multiply 4 by 2. If I multiply them both by 2, what happens? Negative 16 is still less than 8. Or, let's say I divide them both by 2. What am I going to get? I'll get
So negative 4 and 8.
negative 4 and 2. Negative 4 is less than 2. They're still less than, right? The symbol didn't change. When you multiply or divide by a negative number, the inequality symbol flips. So the same statement, right? Negative 8 is less than 4. If I multiply those by a negative 2, what will I get? I'll get a 16 is greater than negative 8, right? It has to flip. And it doesn't just flip just because. It flips because you're changing the sign. If you have a positive and a negative, when you multiply it by a negative number, you'll get a negative and a positive. It changes the meaning. And here, 2 is greater than negative 1. So that's the thing to keep in mind. The big rule is when you multiply or divide by a positive number, it stays the same. When you multiply or divide by a negative number, the symbol, the inequality symbol, will flip. Notice I'm not saying the sign flips, because that's a little confusing, right? So make sure we're remembering the inequality symbol is flipping. Okay? All right, let's just do some. Here we go. So, what do I need to do to get m by itself? Well, I set it up the exact same way as I always do, right? What's the first thing I do? Build the wall. Look at that variable. What do I need to do to m? I need to isolate it. How? I need to divide both sides by 9. Because what's currently happening to m? It's being multiplied by 9. The inverse of multiplied by 9 is divide by 9. I'm not ready yet. So, does it flip? Does the symbol flip? So I get m and then I get negative 2. Does the symbol flip?
No.
No flip. No flip. Why?
You could do the left number on the left side with the variable has to have the negative.
Exactly. The coefficient is the word we're looking for. If the coefficient of the variable is negative, then we're going to flip. If the coefficient is positive, it's not going to flip. Well, let's graph this one. Open or closed? Closed. Which direction? Left or right? Left. Okay. So I go to negative 2. Close it. And I go to the left. Questions on that one? Cool. Let's do the next one. Oh my God, decimals! Why should I not freak out about this decimal?
It's
3, right? Think about this. This is going to be division like you're dividing by 3, and we'll just have to adjust our answer a little bit. Okay? Don't freak out. Make educated guesses about these decimals. Okay, so boom, boom. Okay, what do I notice right away? What do I notice right away about the coefficient of x?
Negative.
It's negative, so I'm going to have to flip that symbol at the end. So I need to isolate that variable. What's happening to x right now? It's being multiplied by negative 3/10. So I need to then divide by negative 3/10. Boop. Now you guys might be thinking to yourself, I have to do long division for this one. Do ya? Do ya?
No.
Nah. What's 9 divided by 3?
3.
3. So x is going to be something, right? We already decided it's going to flip. It's going to be negative, and we put a 3. But it's not negative 3. Not 9 goes into, or excuse me, 3/10 goes into 9, not 3 times, but how many times? 30 times, because we adjusted the decimal, right? If we adjust this decimal one spot over, shouldn't we adjust this decimal one spot over? 30. Also, another way to think about this is, right, 3/10 is really, really small. Yeah, it's going to be 3, but it's going to be a multiple of 3 by a factor of 10. Okay. So then what's the symbol going to be? We had to flip the symbol, so
I mean, our negative 30 is greater than x.
nope, we want to keep x in the front.
X is lesser than negative 30.
Good. X is less than negative 30 because we had to flip the sign because it went from positive and now it's negative. Okay. So now the numbers we put in here would be what, like negative 30, negative 29, 31. Open or closed? Open. Left or right? Be left. Why would it be left? Because we don't flip the whole thing, we just make sure the variable flips because we're dividing by a negative. Okay? 30 to the left. So the big takeaway from today's lesson is when multiplying or dividing by a negative, you have to flip the sign. Okay. Let's do some more. Oh no, now we have to do multiplications. Oh, okay. It's fine. It's okay. We can do it. We can do it. Boom. Circle. All right. What's currently happening to B? It's being divided by negative 3. Being divided by negative 3. So since it's being multiplied or divided, since the coefficient of B is a negative number, we're going to have to flip our symbol. So we need to multiply both sides by negative 3. All right, and that'll cancel. I'm left with B on the left and negative 3 on the right. Now am I flipping or not flipping? I'm flipping. Flip. So instead of greater than or equal to, it's going to be less than or equal to. Open or closed? Closed. Oops. Something weird just happened. That's good. Which direction? Left or right? Left. Great. And the last one we're going to do together. Uh-oh, it's a fraction. Don't freak out. What's currently happening to W? What's currently happening to W? It's being multiplied by 1/6. Is that negative?
No.
No, so what's going to happen to the sign? Or the symbol, excuse me. The symbol.
It's not gonna flip.
It's not going to flip, it's going to stay the same, exactly. So how do I get rid of this? How do I clear this fraction? Thank you, Stephen. Multiply by its reciprocal, 6 over 1, times 6 over 1. The 6's will cancel, the 1's will cancel on W. 1/2, so notice, I'm going to cross cancel this, right? So another way to do this, just multiply cross. 1 times 6 is negative 6 over 2, greater than, so W is greater than negative 3. And remember, no flip. Why no flip? Give me a hand on this one. Why no flip?
Because the negative
Give me a
sign
hand on
is
this
not
one.
really-
Because
Madison?
the negative one has to be the number of coefficient.
Exactly. The negative number needs to be the coefficient. This has nothing to do with the symbol. It has everything to do with what I'm multiplying or dividing by. And so, open or closed? I guess I like negative 3, huh? And then it goes to the right. Okay? Questions on those 4?
No.
We're going to skip the next two. We'll come back to them tomorrow. So let's go ahead and skip to the story problem. We'll do the two-steppers tomorrow. Write inequalities. We want to write, solve, then graph. Marcus wants to buy 5 baseballs. He has 35 bucks. What is the most each baseball can cost? Okay, so first off we need to define our variable. I'm going to use C. For what? Be more specific. Cost of, thank you, each baseball. Let's be honest, what was your instinct? To divide, right?
Yeah.
Wasn't that your instinct?
Yeah.
So if that's our instinct, was to divide, then the actual inequality is not a division problem.
Multiplication.
It's a multiplication problem because you're going to have to isolate that variable using division. So I love that your instinct was division. That's great. That means that we're going to need to divide when we solve. Okay? Cool? So since your instinct was to divide, that means this is a multiplication problem. Because I want to purchase the baseballs, right? Wouldn't going to the store and putting those baseballs in your bag, wouldn't that be a multiplication problem? How many baseballs can I buy? So it would be 5. 5 times what? C. And now, what is the most each baseball can cost? The most. Well, it's going to be 35 over here, but the question is the symbol. The question is the symbol. Like saying at most. Less than or equal to. Yep. Because can he spend more than 35 bucks?
No.
Why? That's all he has, right? He could spend less. So, yes.
Wouldn't, if you're going tax, it would have to be less.
I understand. Let's pretend there's no tax. This is a world of no taxes.
Well, yeah.
Great world, right? Okay, so now we need to do the same thing we always do, right? Isolate the variable. Remember what your instinct was? What was your instinct to do? Good. Are we dividing? Yes, we are. So C, symbol. What happens to the symbol?
It gets isolated.
The symbol
Oh, shit.
stays the same. Why? There's not even a negative anywhere in the problem. No flip. So then we have 7, 8, and then 6. Open or closed? Closed. Left or right? Left. Coolio? I love that you guys are thinking, I need to divide. So we're understanding, if I need to divide, that means that the operation over here, the situation is actually going to be a multiplication problem. Okay, let's do one more together. Melinda charges $4 per hour for babysitting. Man, is she a cheap babysitter. Why isn't Melinda my neighbor? Mrs. Garden does not want to spend more than 25 bucks for babysitting. Cheapskate. What is the maximum number of hours that she can have Melinda babysit? So what's your instinct, guys?
I'm 24.
What's your instinct?
Divide.
To divide, right? You do 25 divided by 4. You're thinking 24 hours?
No, I'm 24 times 4. No, 24. No, 6 hours.
You would think about 6, right? Because you're thinking 4 times 6 is 24. That's a great way to think about it. So I'm going to do H's number of babysitting hours. A lot of you guys might be like, oh, I need to multiply 4 times something to get 25. You're absolutely right. 4 times what? 4 times H. 4 times the number of hours. And then 25. The question is, what's the symbol?
Less than.
Okay? Why?
Because she doesn't want to spend more.
She doesn't want to spend more than that. The maximum, right? She doesn't want to spend more. Does not want to spend more than. So that would be like no more than, right? And so now we solve this one. Divide both sides by 4. And Kobe was right. Do I flip here? No flip. There's not even a negative in the problem. 25 divided by 4. 4 goes into 25. 6 times with how much left over?
25.
Not 25. With 1 left over. So it'd be a 1/4.
Well, that's the point.
Absolutely. You use decimals, Anna, that is fine. Decimals are great. And it'd be less than or equal to. So we plot this 6 and 1/4. What's the next higher up than that? 6 and 2/4. And then lower than 6 and 1/4 is 6. But Mr. Strand, 2/4 isn't simplified. Whatever. It's a number line. Deal with it. Open or close? And she doesn't want to spend more than that, so it should be less. So Melinda can only work for a maximum of 6 1/4 hours. Okay. All right, so your homework is the book assignment you picked up. It is assignment 45. Don't forget about your con lessons. Hopefully you've already gotten a good start on that worksheet, so potentially you might only have the back to do.